Hello everyone, welcome back to Dragonfly Engineering. So in this episode we're going to continue the mini-series about the dual plastic parts that we molded that create this door structure right here. In the last couple of episodes in this series, we showed how we molded the door itself, but now we're going to show how I molded the frame or machined the mold for the frame. So this may be 2 episodes. It's a little simpler to make this frame. But this frame did have some air cylinders that created some side poles for the hinge holes in the side of this molded part. I didn't want to do any post machining or anything, so there's a couple of side pole cores or side core poles that pull out to create a little hole right there. Yeah, and I got an interesting one here. This is one of the first ones I molded after the color change, so you can see some interesting swirl patterns and flow analysis, especially like this corner. It's kind of interesting to see how the plastic flows in, and then at the end of the shot was, or the beginning of the shot was some of this gray color. So anyway, hope you guys enjoy. And again, this will probably be 2 episodes. It may spill over into 3, depending on how much footage I got of actually molding the parts. So, hope you enjoy. Thanks for watching Dragonfly Engineering. Whew. Okay, I got another mold base here from American Quality Molds over in Indiana, USA, not sponsored. And this mold base is going to be used to make the plastic frame that the square door inserts into. So let's open it up and see what we got. So this is a 12 by 12 inch A and B side mold. Of course the airplane flies over. So it's just got a front and a back plate. There's no transition plates or stripper plates or anything like that. But it's got an ejector plate that they add with all the bushings and pretty much everything else you need to build a basic mold. I don't think there's an alignment ring though. So yeah, an alignment ring goes here, but you can buy those at PCS.com. Also not sponsored. All right. It's like Christmas morning. And then this is the ejector plate. 2 plates that bolt together with hardware. And then the ejector pins, or guide pins for the ejector plate. Okay. Let's see. Need a couple of screwdrivers to break the vacuum on the 2 A and B side mold parts, or halves. So they give you these pry slots here because it can be a little tricky to open up that without a prying tool. Basically the vacuum that's created in this oil papered gap. And like I mentioned before, it's best to open these molds, aluminum molds, by just giving it a quick continuous pull so that you don't lock the pin up in its high precision bearing hole. You know, like an angle lock, as soon as you get off angle, the pin in the hole will jam up. So if you can just pull it open before it can jam, then that's best. Sometimes I'll even push the B side that way and then pull the A side this way. Oh, except that well, actually I shouldn't push because I created another vacuum. All right, so we'll break the vacuum again, and now I'll just pull forward. Nope. Let's try that again. Yeah, this cardboard isn't helping. See there, I've got a vacuum again. I guess I could just pry like that. Okay, let's try this one more time. I don't want to pull the whole front off the table either. Yeah, there we go. Okay, I did it that way. Okay, so that's open. Then they put this piece of wax or oil paper between the two halves to protect the mold surface that's ground on a surface grinder. All right, so I need to check out the CAD and see which side we're gonna load on the mill first to start machining the cavity. All right, we're gonna start with the A side, which is this one. The A side is sometimes the simpler side. In this case, it will be more simple because this is gonna be a traditional mold where the ejector pins are on the B side and the A side needs to release the part when the mold opens. So there's less three-dimensionality with the A side of a mold. You know, the plastic part usually grabs onto a core, which should be on the B side where the ejector pins are, because the plastic shrinks around the core and tenses up around it. And since it's shrinking, it's releasing from the cavity on the A side, is the general theory of mold design. But rarely in my case, it's so straightforward because we'll wait for the airplane. Because usually parts have equal amounts of cores and cavities on both sides, in some cases. If you're molding like just a project box or a Tupperware bowl, then it's probably a little more straightforward. But a lot of the more complicated parts, it's not always obvious which side should go on the A or the B side so the part ejects correctly out of your mold when it opens. All right, so as usual, we've got to hammer out these guide pins, and then I'll load this A side into the mill and we will square it up and start cutting our cavity. All right, so we'll look for the origin. Note that when we load it in the mill, and then we'll find the zero of this face off of the origin of the mold. All right, so let's get the mill set up and we'll load this and start cutting. All right, I'm checking for the origin. And we'll stick this thing on our double vise. I flipped the jaws around on the back, but I've got parallels that stand slightly higher than the top flat of the Kurt vise here. And then the same on the all four corners. Gives me the ability to pivot when I knock in squareness of this block if I need to, because this is effectively cantilevered right here. I'm gonna run an indicator around. So I'm not going to tighten too much, but just enough where I can still bump it around if need be. And we'll switch to a tool holder. And we'll clamp our indicator on. Always remembering to pull this off before you turn the spindle on. I saw a guy forget that once, and it spun around for a while and flew across the shop. So usually I have to shim the front of this mold a little bit with these angle lock vices, because when you tighten these vices down, they tend to roll your stock a little bit. So, and usually it's 2/1000, but we'll measure and see what we got. I'll bring the indicator down. Yeah, so just about 2/1000 there. And then left to right. Right around 1/1000. I may be seeing a little drag just from the tool, which relaxes when I stop pulling. So yeah, it looks like we need to add those 2/1000 shims. Let me pull the indicator off the edge. And I'll lift in the middle, and then I'll put a shim right on the top of this parallel, which is sticking slightly above the surface of the vise. And I'll do the same on this side. Okay, and then I can tick-tock it too now on this parallel. We'll tighten it down. and then see what we get. All right, and now we'll drag it along. Yeah, change about half a thousandth. Check the side, still at 0. All right, so I may need to tap this in a little. Actually, maybe just tightening the vise will bring it in. Not really. All right, I'd say we are planar. So now I'll just find the X and Y with the Heimner XYZ. Okay, now we'll find the center of our block. I guess technically I'm finding the center of the block, not the origin marker, but it's always good to keep the origin marker in mind. The origin stamped on the corner of the mold block. I guess in this case it's mostly important for keeping the orientation right, so you don't have your cavities 180 degrees out or something like that. Okay, so new part setup, work offset, X, store. And I'll find this dimension and then just divide by 2 and set the origin to the center between these 2 readings, which is the center of the block. All right, so 304.84. $152.42. So that shows that either the mold block or my measurement is within 2 thousandths, about 1.5 thousandths over 12 inches, which is pretty good. So go back to half of that, 152.42 millimeters, which is 6 inches. And that 0 is the same as the last 12-inch mold block that I have in here. So we are set. All right, I'm going to set the 1/2-inch tool height using a touch off method. So I'll just look for first cut and then lift off. I think in this case we'll lift off 15 microns, which is a a temperature compensation. I can do this in the center of the mold block because we're going to machine away this material that we're touching off. But I have to make sure that I have an additional touch-off area that's benign. So I actually will probably touch there, but then really set the height in this location, which is within 1/2 thousandths of that location, or 12 microns. Okay, there's first cut. There's a negative rake on the end of these end mills, so you get like a little ring cut on the outside. So I'll back off 20 microns, and then I'll move in Y and see if I'm still cutting the surface. And I'm just barely skimming the surface. Seems like I got a little bit of a, maybe a rake in my, or what's the term? Tram maybe needs to be looked at here. All right, but I'm kind of skimming along the grind, and I'm seeing some highs and lows, which agree with what I see in the grind witness mark. And we'll come this direction. All right. So I'm just skimming along the grind edge here at 0. So I'll call this 0. So that's my initial touch off. And then this is me just kind of kissing the highs of the aluminum grind. This is all a few microns or so. And then back here, I roll off. So my mold block may be off by, 6 microns or so. But I think that's good enough for this part. All right, but I still want to compensate for spindle growth on temperature. So I'm going to move up another 20 microns. I think I'll do 20 just to be safe. because we're probably going to run 3,000 RPM on this spindle. And most of the spindle heat comes from just extremely high RPM. Like if this was running at 10,000 RPM, I'd probably raise the tool up 40 microns or so to allow for the growth, thermally induced growth.
Yeah, 1 second. All right, we'll see you Monday.